And welcome to the final part of 3.1. We have 2 more problems to go. My name is Gregory Carlson. All right, an object was launched into the air with an initial velocity of 256 feet per second. Find the number of seconds it will take to reach its maximum height, and what is that maximum height? So, as a reminder, the formula for height is h of t. If we're in feet per second, the formula is negative 16 t squared plus vt, where that's the initial velocity, plus the initial height. In fact, if you wanted to, you could even put a 0 there to say initial height. All right, so let's plug in our values that we know. Nothing to plug in on the first part. It says the initial velocity was 256 feet, so that's pretty fast. 256 feet per second. And it doesn't say anything about an initial height. That's a 6 right there. It doesn't say anything about an initial height, so we'll just assume that's 0. So we'll just assume the initial height is 0. So how long will it take for the rock or the object to reach its maximum height? Well, that's just a matter of finding the vertex. So x is equal to negative b over 2a. Hopefully you've memorized that by now. So that's going to equal negative 256 divided by 2 times negative 16, or 256 divided by 32, which is 8. So if you launch an object into the air with an initial velocity of 256 feet per second, then that means it'll be at its top of its rise 8 seconds after launch. Now, to find out how high it is, we just plug in 8 for t. So let's find h of 8. That's the y part of the vertex. So that's going to be negative 16 times 8 squared plus 256 times 8. So let's see if I can type this into the calculator correctly. 8 times 8 is 64 times 16. So I get negative 1,024 plus 256 times 8 is 2,048. Add those up and you get 1,024. So the height reached, the maximum height reached, will equal 1,024 feet. And in fact, 8, 1,024 is the vertex of this parabola right here. One more to go. A company has used a statistician to find that the number of the amount of money that people spend on average in their district of stores can be represented by this curve. Don't be afraid of these scary looking numbers, even though they're decimals. If the graph is in millions of dollars, in what year during this period was the amount spent a maximum? So once again, this is just a parabola question. We see we've got a parabola right here, and it's asking for the maximum. When did they spend the maximum amount of money? So once again, that's just going to be x equals negative b divided by 2a. So this is a, this is b, this is c. So that's going to be negative 71.33 divided by 2 times negative 4.257. So let's calculate what that'll be. Let's do 2 times 4.257. So that'll be negative 1.33 divided by negative 8.514. And so let's divide that. 71 point, we see that it's a positive number, divided by 8.514, and we get 8.3379. So what that tells me is that around the 8th year is when this curve hits a maximum. So if 0 is 2,000, then that means around the year 2008, maybe try that answer, is when spending hit a minimum. Then in that, a maximum, I mean, and then we had a recession, so the spending started to curve back down after that. So I don't know, try plugging in 2008 as the answer to that problem and see if it's right. If it's not, send me an email. How much money did they spend in millions of dollars? Well, let's just take this number and plug it in. So we find F of 8.3779. And so that's going to be negative 4.257 times 8.3379 squared. I'm just plugging it into the equation. Plus 97.88. So I just took my answer I got and I plugged it in for x and x into the formula. And I'm not going to crunch this all out on my calculator because I've already done it. But when you crunch that all out, you should get the following number, 396, I think it's 0.68. So that's the number you should get when you crunch that all out. And so it's going to be approximately, if we round to the nearest million, $397 million is how much consumers spent at those stores in the year 2008. So that's how you do it. These applications are pretty good. You can model business expenditures. You can model gravity very easily. And I know this was kind of a long section, but hopefully all of this made sense. You won't be able to do this unless you practice it. So please practice on your homework, and we'll practice in class. If you liked this video, please like or subscribe, and leave any questions in the comment section. That's the end of section 3.1. I will see you at 3.2. Have a great day.